Hello. We're just finishing up a few odds and ends on a trig review for our test tomorrow, so hopefully you'll find this helpful. I will begin now. I want to say that part of the test is going to be simplify and verify, which is very much like it, except on verify we give you the answer. And on simplify, you just kind of stop when you can't simplify it any longer. And on those, I just want to go over the strategies. We had a trig suitcase that we carried around for a while, and in it was change to sine and cosine. So on sine and cosine, a lot of the problems, there is at least a step where you're going to do that. Change to sine and cosine, and then everything will simplify. Factoring is a big one. And lastly, I would say, well, not lastly, almost lastly, sub-trig IDs. For example, if you see sine squared plus cosine squared, then you would substitute in a 1 and other trig IDs as well. And adding algebraically. So just remember when you're adding in algebra, for example, suppose something like this just came up on your paper in the middle of a problem. I'm not going to simplify this because I'm making it up. I'm just showing you, reminding you how to add these two. To give these like denominators, this denominator and this denominator must appear in the common denominator. And they're connected by multiplication. So you're going to ask yourself, what does this expression need so its denominator looks like this? Well, all it's lacking in the denominator is sine x. So I'm going to multiply by sine x over sine x. That creates a sine squared x plus, remember that plus does not disappear from the numerator. Then this expression would have to be altered to look like this. It needs a cosine squared. And you'll remember this from your algebra days. It's just that we're working with trig expressions in the middle of our algebra. So this times this gives me the common denominator. That's why I picked it. And the new numerator is cosine cubed x. Alright, so like I said, this is not a real problem that I'm expecting to simplify. I'm just reviewing how to come up with a like denominator. So I want you to be strong in that area for tomorrow's work. Alright, so enough for strategies. I'm not going to do any more simplify and verify problems tonight because I've done a good job of that Thursday night, Friday, the weekend, and today in class. So I would advise you to practice those that we did. It's amazing how close some of those are to the test problems. So if you go back to Thursday night's video, the problems we did on the overhead on Friday in class, the weekend's video, and if you would practice those simplify and verify problems, cover up the work, try to recreate it, it would be very wise to do that. Where I want to work tonight is on solutions, finding solutions. So we'll do one more of these. This time I'm going to mess with the angle. In this case I actually tripled it. So when I triple the angle, it messes with the range in which I can look. So the normal problem, when it gives you the range, that is speaking about x. But this problem has tripled x. So we're going to have to triple everything. So 0 times 3 is 0. 2 pi times 3 is 6 pi. So we're going to go around and around and around the circle 3 times to find all the answers for this one. So always check the range before you get started. Move the 1 over, divide by 2, and you're asking yourself, what does this whole thing have to be so that its cosine is 1/2? And I cannot divide both sides by 3. This is like the marriage that we're trying to keep it together. Until I actually take the cosine, then I can divide by 3. I'm actually taking the cosine now as I look on the unit circle, and I'm finding places where its cosine is 1/2. So I found that to happen at pi over 3. That's where the first coordinate is 1/2, and 5 pi over 3. Now, because I'm allowed to look at more than one circle, I'm going to spin this one. So when I say spin, here's what's in my thoughts. I'm adding one complete circle to this. So I'm adding 2 pi. But since it's in thirds, I like to think of it as 6/3 pi, which is the same as 2 pi, but it's easier to add. 1 pi plus 6/3 pi, 1/3 pi and 6/3 pi is 7/3 pi. Is that out of range? Is 7/3 past the number 6? It is not. So now I'm going to spin this one, and I'm going to add 6/3 pi. 6 and 5 is 11/3. And then I'm going to spin this one by adding 6/3, which gives me 13/3. And then I'm going to spin this one. So I'm going to add 6/3 to it. And 6 and 11 are 17/3. And when I spin this one and add 6, I get 19/3, and that's greater than 6 pi. So I ended up with 1, 2, 3, 4, 5, 6 answers when I go around 3 times. Notice now the answer, I have taken the cosine. Once you look at the unit circle, you have taken the sine or cosine. Now I want to know what x equals. So I can now divide every single one of these by 3. So when I divide this by 3, dividing pi over 3 by 3 is like taking the 3 over 1 and flipping it where it becomes 1 over 3, and then when I multiply, do I not get pi over 9? So pi over 9. And when I divide this by 3, it becomes 5 pi over 9, 7 pi over 9, 11 pi over 9, 13 pi over 9, and 17 pi over 9. Those are my final answers down there, and notice there are 6. And usually, not always, but usually when I triple an argument, there's a triple angle there, there are 6 answers. When it's double, there's often 4. So when I quadruple the argument, there's often 8. All right. I think that's really all. I didn't get to review that today, but everything else was already reviewed thoroughly since Thursday night. So please go back and look at those problems again. As again I said, a lot of them are very, very close to test problems. And so it would benefit you by practicing those. Other than that, I just would like to say that on the test, I wanted to remind you that the cards that came down today were once again the Pythagorean IDs, which are starting with sine squared plus cosine squared equals 1. And the other 2 that are derived from that, and the deathbed ones, sine over cosine, cosine over sine, and the reciprocal functions. And of course, the regular definition of sine, cosine, and tangent. So please look over those as I showed you today. Those cards are coming down for the test. And the ones that are still up there are the double angles, half angles, and the sum and difference formulas. So with that in mind, then that's it for tonight. I want you to spend some more time studying, and I would like you to do me proud tomorrow. Till then, over and out.